All right, hello everyone. We are here to do a video walkthrough of practice quiz number 2 for LT number 9, Polygons. Let's start with standard 9.1. 2 parts to this, but the first part, we need to label the parts with its number from the diagram. This is all about matching parts to the shape. So first step here, you can go any order you want. We'll go top to bottom here. Now, apothem. The apothem is the segment that connects the center right here with the middle of one of the sides. It's perpendicular. So if we look out, my key here, I look for where's that perpendicular, that 90-degree symbol. That means the segment connecting the side length in the middle to the center of my polygon is the apothem. Great. Central angle. Which angle is at the center? I see 3 angles, 1, 5, and 6. Look for the one that's at the center. Must be number 5. The exterior angle. Remember, exterior is a synonym for outside. Which angle is outside? 1 or 6, 1 is outside the pentagon. Therefore, our interior angle must be angle number 6, which is inside. Lastly, the radius. The radius is the segment that connects the center to a vertex. So 4 here is the segment connecting those two things. Lastly, the only number I haven't used yet is 3. That would be a side length. Feel free to go process of elimination, If you know what the side length is, do that one first, and then work backwards. All right, let's go down. Find the requested angles for a regular dodecagon, 12 sides. All right, so sketch the shape, optional. You don't have to sketch it. Dodecagons are hard to sketch. If you want to think about it, top and bottom are both flat. They look the same. And then we've got to get 1, 2, 3, 4, 5, kind of like that. And then this side is flat. Again, it's not that important if it's great. Just a sketch to help you think about it. The measure of one central angle. How do we find the central angle? It's 360 divided by the number of sides, which is going to equal 30 degrees. The sum of the interior angles. We can do 180 times 12 minus 2, 180 times n minus 2, the number of sides minus 2, which equals 180 times 10, which equals 1,800 degrees. Now, the measure of one interior angle. To find the measure of one interior angle, to do that, we take the sum, which is 1,800, and we divide it by the number of sides. There are 12 sides. So that equals 150 degrees. Again, the sum just came from this right here. We take all the interior angles added together and divide it by the number of sides. Lastly, one exterior angle, 360 divided by the number of sides equals 30 degrees. You could also have found the exterior angle by being it's the same as the central angle, or we could have done 180 minus 150, because 180 minus the interior gives us the exterior. Either way works. So that is standard 9.1, 2 parts to it. All right, let's move on to 9.2. So if the measure of one central angle is 18 degrees, find the number of sides. Turns out, if we do 360 degrees divided by each angle is 18 degrees, how many are there? We're going to get 20 sides. Number 2, if the measure of one interior angle is 144, find the measure of one exterior. Now remember, exterior plus interior, EA plus IA equals 180. So if I do 180 and I take away 144, that's going to give me 36 degrees, which is the measure of one exterior angle. Number 3, if the sum of the interior angles is 1,980, find the measure of one interior angle. We need to find n. We need n, the number of sides. All right, we need n, the number of sides. So let's think about, how do we get to this 1980? What equals 1,980? Well, our formula we can use is 180n minus 360. That gives us the sum of the interior angles. We need to solve this out for n. We know how to do that. We did this in LT8. Add 360 to both sides. We're going to get 180n equals 2,340. Divide both sides by 180. And you're going to get n equals 13. So there are 13 sides to this shape. So then again, that's not what we're looking for here, though. What are we actually trying to solve for? The measure of one interior angle. Now we know the sum is 1,980. We divide that by the number of sides to get our answer of 152.3 degrees. All right, again, we took the number of sides that we figured out by undoing the sum of the interior angles and divided the sum by that number to get one interior angle. Lastly, number 4, if the measure of one exterior angle is 40 degrees, find the sum of the interior angle. So we have one exterior, find the sum of the interior. So again, we need n. We need to find the number of sides. So 360 divided by 40 gives us 9 sides. Okay, that's not what the question is asking for, though. The question is asking, what's the sum of the interior angles? To find that, we do 180 times 9 minus 2, which is 180 times 7, which equals 1,260 degrees. All right, that is standards 9.1 and 9.2. Let's move on to the back to our golden standard 9.3. All right, find the area of a regular pentagon with an apothem of 16 centimeters. Okay, so step 1, how are we going to do this? Triangles are our key, specifically this isosceles triangle right here, where the radii are the congruent sides. And if we know we have an apothem of 16 centimeters, that means this distance right here, the apothem, is 16, and we know it creates right angles like that. That's what the apothem does. So let's take this triangle and let's think about it up here. I've got this triangle right here. Now, what else do I know about it? I know my central angle is 360 divided by 5. So that's 72 degrees. So this angle up here is 72 degrees. And I know this apothem right here is 16 centimeters. These two sides are congruent. Cool. What do I need here to find the area of this triangle? If I can find the area of this triangle, I've got it. What am I missing? I'm missing the base. I need the base. So to do that, I need to solve for a side. I'm going to pull out this right triangle. It's going to look like this. So this right triangle looks like this. I know this side is 16. This is still the height, still the apothem. All right. Again, this apothem, if you want to think about where it comes from, trace the side like that, like that. Everywhere that you see in green right there is the same segment. I need to solve for that base right there. Now, this angle up here, how much is this angle? Turns out the central angle is 72 degrees, and I took half of that triangle. So 72 divided by 2 gives us an angle of 36 degrees. Now, to solve for that base, I'm going to need to use trigonometry. I got a side and angle. What sides do I have? Opposite and adjacent, so I'm going to use tangent. So tangent of 36 degrees equals opposite b over adjacent 16. To solve this, I'm going to multiply both sides by 16 over 1 times 16 over 1, which gives me 16 times the tangent of 36 degrees equals b. So b equals about 11.62. Okay, let's think about what that means. That means in this triangle right here, again, this is the same triangle. The height is 16. This right here is 11.62. Careful, that base is not the base of the entire isosceles triangle. This base is the base of only the right triangle right here. So it's just this right here, which means this length is also 11.62. So the entire base together is 23.24 centimeters. It's one of the most common mistakes we make when we're doing this, is forgetting to look carefully at our isosceles triangle. So our triangle area is our base, 23.24, times our height of 16 divided by 2. So our triangle area equals 185.92 centimeters squared. Are we done? No, I don't want the area of the triangle. I want the pentagon area. So my pentagon area equals my triangle area, 185.92, times how many triangles there are. 1, 2, 3, 4, 5. So I multiply my one triangle by 5 to give us a total of 929.6 centimeters squared. That is our golden standard. It's a lot of steps. It's a lot of steps, I know. But take it one step at a time and think carefully about where each number belongs. What are you doing? Why are you doing it? Okay, let's move on to standard 9.4. So this is a bit of like polygon problem solving. What are we given here? Think about what we're given. First thing I see a regular hexagon, and then I see this triangle over here. And I know I have one length that is 4. I don't know anything about that hexagon. No side lengths, no apothem, no radius. How am I supposed to find the area? Well, what can I figure out about the hexagon? Well, I could always figure out something about its angles. If you can't figure any side lengths, try angles. I know that the measure of one interior angle for a hexagon is 180 times 6 minus 2. That's the sum divided by 6. So that's 180 times 4 divided by 6. So that's 720 divided by 6. So that means each angle in this hexagon is 120 degrees. So that one, those are all 120. Now, how the heck does that help me? Well, if I could figure out an angle in this triangle over here, I could use trigonometry to figure out the other sides, namely this side right here. And look at this. If this is 120, what did those two angles form? They form a linear pair. So this angle must be 60 degrees. Well, that's pretty useful now, because now if I know that's 60, I'm going to take that triangle and I'm going to draw it right up here. 4 inches. I know this is 60, which means this must be 30. Look, a 30, 60, 90 triangle. My short leg is 4. So that must mean what? Fill in the other sides from your special pattern. This side is 4 times the square root of 3, and this side is 8. So that means everywhere around my triangle, my hexagon, excuse me, these side lengths are all 8. If you don't remember your special right triangles pattern, you could also use trigonometry to figure out these two values. This value is the same as 6.93 rounded. You could do it either way. Great. Okay. So what's our next step here? Well, next step we got to do, we got to find the area of both this triangle and the area of the whole polygon. All right. We need to find the area and perimeter of the whole thing. Okay. So let's find the area of this triangle. So the area of this triangle equals 4 times, we can do a decimal, 6.93 divided by 2. So the area of this triangle is what? 4 times 6.93 divided by 2. 13.86. So that's the area of that little triangle. Let's come back to our hexagon and let's find the area of the whole hexagon. So think about your isosceles triangle. Looks a lot like that. We know this length down here is 8. We know our central angle is 360 divided by 6, which is 60 degrees. So that up there is 60 degrees. Keep going. Pull out the right triangle. We know this is 4. We know this is 30 degrees. It's half. We need to find the height of that triangle. We need to find the height. Turns out, if you use tangent, you can either recognize with special right triangles that that's the same 4 root 3 or 6.93, or you could use tangent. Tangent of 30 degrees equals 4 over h. Either way, you're going to come to find that h equals 6.93 as well. So back in this triangle, that means in our hexagon, we've got 8, 6.93. Find the area of that triangle. So our triangle area is 8 base times 6.93 height divided by 2. So our triangle area is 27.72. And our hexagon area is 27.72 times the 6 triangles to give us a total area of 166.32 centimeters squared. Now, our goal in the original problem was to find the area and perimeter of the whole figure. So that means our total area is going to get a little crunched here, is the hexagon plus that little side triangle. So we have to add those two together, which gives us a total area of 180.18 inches squared. So that's my total area. I'm not done yet, though. I need the total perimeter. So the total perimeter is the distance around the outside. So how far is it around the outside of this hexagon slash with the triangle bump? 8, let's see, 8 plus 8 plus 8 plus 8. Careful, it's not just 6/8, because here we have to go out to 4, and then down this side, which we know is this, which is 6.93, plus 8. So there are 5 sides of length 8 plus this 4 plus 4 times the square root of 3. Add them all together. 8 plus 8 plus 8 plus 8 plus 8 plus 4 plus 6.93. 6.93 should get you 50.93 inches. There's the perimeter. There's the area. All right, my friends, hope this was helpful. Good luck with your LT9 Mastery Quiz.